Dear students and candidates, aspirants who are preparing for the academic and other competitive examinations, today we are going to give our third series of the lecture on kinematics. So, to understand very well, must watch this video lecture up to the end and like, share and subscribe my YouTube channel. Now, velocity time graph, position time graph, and acceleration time graph. In kinematics, there are three graphs: position time graph, velocity time graph, and acceleration time graph. We are going to discuss one by one. Let's see. Position time graph. What will be the position time graph? There are two quantities to show the motion, to represent the motion. Independent variable. Second is dependent variable. In this graphical representation, time is considered as independent. And other displacement velocity acceleration, all three comes under the category of dependent. So this is the rule to show the graph and graphical representation. We keep always x axis for independent quantity and y axis key for the dependent quantity. So in position time graph, time will always at x axis and displacement or position or velocity or acceleration always will be at y axis. Let's see more about the graph. There are several graphs for position time graph, position and time graph. Graph number 1. This is the time, this is the position or displacement. Time always in second, position in meter or centimeter or kilometer. So always in this is the S. Look this graph very carefully. Here the graph line, the straight line is parallel to time axis. Means time is changed continuously but positions of particles or body remains unchanged, and in this situation, in this condition, the velocity of particle is 0 because here the slope is 0 degree, so velocity will be 0 degree. Therefore, what is the point? The point is that line parallel to time axis on ST graph, position time graph, represent rest position of particle. Rest position of particle or body. Therefore, this point is very important. If graph is parallel to time axis, then it shows a rest condition. And graph number 2, what will be second graph? Here will be second graph, time position. This represent the straight line and start from the O origin and it's make an angle theta. यहाँ पर जो एंगल फॉर्म हो रहा है वो थीटा का हो रहा है and therefore this shows a uniform gradient. Means you look, the gradient value is always equal. If you want to know at this point, you look theta, you know at this point always theta, theta, theta. So the graph gradient is uniform, the value remains unchanged and therefore this shows the uniform velocity. Uniform velocity क्या होता है? If body covers equal displacement in equal interval of time, then this is known as uniform. So, a straight line with the same gradient shows the uniform velocity. It is your uniform velocity. So, this graph shows uniform velocity. Now, how can we calculate the velocity by position time graph? There are few important points. Point number 1, slope, velocity. Slope shows velocity. Slope, velocity. See, time, position, this angle is theta. This is similar to equation y equal to mx plus c, where c is the intercept at y-axis. The value of c is 0, y is equal to s and x equal to t. And if you represent here s equal to mt plus 0, then you get s equal to mt, m equal to s by t. So m shows a gradient. M shows a gradient. M equal to s by t, gradient. S displacement, t time. So gradient equal to velocity and gradient is given equal to tan theta. So our formula will be tan theta equal to m equal to velocity. This is a very important point. slope of position time graph gives velocity. Now look this O A B. This is the area. What is the area? Area of right angle triangle is 1/2 base into height, OB into AB. OB T and AB S. So you get area is equal to displacement into time. Now point number second is that time velocity O, A and B. If we consider slope of A is theta, slope of B is phi. Theta greater than phi. So VA greater than VB. VA greater than VB. Greater slope with time axis represent greater velocity. Slope increases, the velocity will increase. Okay, and to calculate the velocity, simply you keep the angle. If you assume theta is equal to 45 degree, phi is equal to 30 degree, then velocity of VA equal to tan 45 means 1 meter per second, and VB equal to tan 30 is equal to 1/√3 meter per second or √3/3 meter per second. So greater slope gives the greater velocity. These are the important features of the position time graph. One more, time, position. This graph. This is represent a non-uniform. O, A, B, C. This represent a non-uniform graph because slopes are varying at point O to A the different slope, A to B a different slope, and B to C the different slope. So slopes are varying. It's represent non-uniform speed. For instantaneous time, position, this graph. This is the variable velocity. This graph, a position time graph, gives variable velocity. How? Because this is varies each and every point. This graph is varying each and every point, and therefore, if you want to calculate this graph instantaneous velocity, what will you just keep the tangent, just keep the tangent here, point O A. So at point A gives you instantaneous velocity, and instantaneous velocity is given v is equal to ds by dt. ds by dt. Here one more important point comes out. What is the point? This point. So according to position time graph, we can categorize the velocity as uniform, non-uniform, average, instantaneous, variable. So just giving by the graph, time, position, O, uniform, time, position, non-uniform, time, position, variable. Velocity is constantly increasing. Velocity is constantly increasing, and you want to get the velocity at particular point. Let's assume this is the point. Then at this point, a velocity will be instantaneous, and the method to get the instantaneous velocity, you just make a tangent at this particular point. Okay, this tangent gives you, this is the gradient, and this at this point, this is represent instantaneous velocity, and v is equal to ds by dt. This is the instantaneous velocity. So very important point here, velocity is the differentiation of displacement. Velocity is the differentiation of displacement with respect of time. Okay, you get here velocity differentiation. Okay, and so one point is more, displacement is the function of time. Displacement is the function of time. Okay, now for average velocity, O, this is the uniform velocity graph, and now drop a perpendicular, A, one other perpendicular, B, just to make this line. Now C and D, T1, at point B is T2, and at this point S1, and at this point is S2. So you can say this is the E point, and what is the value of CE? The value of CE will be difference S2 minus S1, and value of DE t2 minus t1, and here this is the slope theta. So according to this graph, the average velocity will be given as average velocity v is equal to s2 minus s1 upon t2 minus t1. By this formula, you can calculate the average velocity. Since velocity has some features, what are the basic feature of velocity? That it is vector, so it will depend on time, on direction and magnitude. Okay, so velocity can be negative, can be positive, can be zero. Very important point. Velocity can be positive, negative and zero also. But point should be remember that speed never zero, never negative, always positive, because speed is the scalar quantity. So you can calculate by this diagram the average velocity of the particle, and this is the formula to calculate the average velocity. And so you can write this formula: v is equal to delta s by delta t. This formula shows a representation of average velocity. Then what is the concept of instantaneous velocity? Then what is the concept of instantaneous velocity? It's very important. Look, how can we create a difference between instantaneous velocity and average velocity? Simply you look both diagram, this diagram and this diagram. In this diagram, we want to calculate instantaneous, and here average. We want to get at a point of time. The velocity at a point of time is instantaneous. Velocity at a point of time is instantaneous. Velocity of the total span of the time is the average velocity. So if delta t tends to 0, means the time interval between A and B become 0, not become 0, tends to 0. That means difference is reducing and nearly go to 0, but even not it's 0, then this terms is converted into instantaneous velocity. Means delta t tend to 0, then limit delta t tends to 0. So you can write here limit delta t tends to 0, delta s by delta t is equal to ds by dt. Okay, this is the instantaneous velocity and this is the average velocity. So candidates and aspirants, there are few important points regarding the position time graph. Clear? Now we also tell you some very important point, that here you are looking at displacement and velocity how related. Means velocity is the differentiation of displacement with respect of time. So you note another point also, and what will be your point? This point will be known as velocity displacement is the integral of velocity. Displacement is the integral of velocity. Displacement, integral of velocity. Since velocity equal to ds by dt, then ds equal to v dt. So integration ds equal to integration v dt. This is the formula to get the displacement by velocity, and this is the nature of variable velocity. So the point is quoted: displacement is the integral of velocity. Now, if anything is given here, and then how can we calculate the displacement by the velocity? Okay, this is the other part of our teaching, and we discuss this part in our coming next video. Now, one graph is more also here, and this graph is t position or displacement. Look this graph. Here the slope theta is 90 degree. Theta is 90 degree. Okay? But what is the value of tan 90? Tan 90 is equal to infinite. And you know that m equal to v equal to tan theta. Then v is equal to infinite. So this graph shows the infinite velocity of particle, and how it is possible for one dimensional motion that displacement is not changing, but time displacement is changing, but time is not changing. At a constant time, displacement is continuously changes. Okay, look, time is fixed. Time is here fixed, but there are different displacement. So for 1D, this graph is not possible because velocity cannot be infinite. So this is not possible. This is increasing velocity. Now look another graph. This position. This first increasing, then decreasing. Okay. Therefore, few important points regarding the position time graph. Just note that, and this is the summary of our this article. Okay. The summary of our article. Velocity will be calculated by the slope of ST graph. Means velocity can be calculated by ST graph. Very important point. If theta is greater than 90, velocity will be negative. Theta less than 90, velocity will be positive. Theta is equal to 90 degree, velocity will be infinite. There are 3 points, okay? And these points on the graph, theta less than 90. Theta greater than 90. Third, theta 90. So, positive velocity, negative velocity, velocity equal to infinite. Velocity increasing because slope is increasing. Velocity is increasing. Next, velocity increase, then decrease. Velocity increase, then decrease. So students, these are the few important graphs. Now one more graph can also written here. Time, position, A and B, theta, theta. So the slope of both bodies A and B are same. So this is show the equal velocity and never cross to each other. So both relative velocity VA equal to VB, their relative velocity in the same direction will be 0. Okay? Relative velocity in the same direction will be 0 and in opposite direction will be just add up and get 2 times. Okay? Now look another graph. This graph, time, position, A, B. They are intersecting at particular points. This is also a relative velocity, theta 1 and theta 2. Okay? Here, theta 1 greater than theta 2, so A moves faster than B. And so, A overtake to B at particular points of time. Now, dear students, This is very sufficient to understand the graph regarding the position time graph. So I hope that this video lecture will be very helpful to all if you watch initials to final, means up to end. So please like, share and subscribe more and more to knowing about the kinematics. And if you have any queries, then you can comment in my comment box and you can instantly ask any kind of problem with me. And thanks for watching.